how to make the Arizona sediment layers model. Just 4 steps. Step 1, pick the interface. Step 2, set up parameters of workflow. Step 3, one click to go. Step 4, quality control the result. Okay, we start from step 1. This is a model we want to make. We show how to pick an interface. For example, we pick the top of the model. This we can zoom in. Okay, the peak. If we pick something wrong, we can delete. And redo this. If we think we need a mold, we can mold the peak. Okay, like this. So pick interface just need time. It's very simple. For this model, we already picked. I picked for the demo. We can simply load. That's the picks I did. This include, for example, the top, the very top of the model. You can load this. That's the top. Let's make bigger. We see the top is not very good. Usually we make the model on the top of the model. We can change it. Okay, just like this. Very simple. So this looks better. It should be the model top. We designed the model as flat one, flat model. Okay. We other pics like this. What's this? This previous one maybe. Okay. We can load all the pics. This one already loaded. Okay, that's all the pics we need. Okay, we go to next step. Set up parameters. Yeah, set layer. We design model the simplest one, like constant velocity model. You can design model with complex parameters, like a real rock something. Need more data. You can set the model like a density model, P with velocity, shell with velocity, and gamma ray, sonic log, and more. You can set up. Here we just do a forward modeling. Let's see, we know the parameters, but in the industry we don't know the parameters. That is another type of problem. We call inverse problem. That's a forward problem, right? So for the inverse problem, it's a big topic. Like inverse problem, like we drill the earth to pick up the rocks underground. We test the rock, get parameters. That's a kind of inverse, right? That's physically do something. And we can do mathematically, like CDP analysis for velocity spectrum. That's another example. And more well-known example, like migration-based inversion, like pre-stack time migration inversion, like using a time domain image gather to get a velocity or anisotropy, something like that, or depth domain pre-stack depth migration image gathers. We analyze the velocity, anisotropy, or fracture orientation, something. Any kind of model we can do, and maybe we can use the post-stack seismic data to get impedance. It's another inversion, right? It's well known as a well-known method, like using post-stack seismic data to get impedance reflection coefficient. Okay, that's all kind of inversion model we can do. Okay, I think two problem for the process like set up workflow. All other workflow like so that's for workflow. Interpretation. That's the function we interpret the peaks into homogeneous peaking grid, or set up a parameter like this we just show, and make a sediment model, and we insert inclusions like this. This one. That's the inclusions. And we merge the snapshot and QC the model, and this one we can there's another QC, but in the workflow we only include 11, 12, 13, 15, 16, 17. You can design your workflow with simple one, complex one. That's easy, right? Okay, let's submit that job. Just one click, like we press F2. Okay, we got the result. That's two result. That's the final model we see, and this one we merge the snapshot. We can see. We can play the snapshot like this. Okay, that's good. And this, that's the final one, like this. That's the final snapshot. And what's this? The last we can show another display like this. Let's show two. Okay. Oh, that's the same one. We can see that that's the same one. Okay. So we did run the job just one click, right? And the last step, QC result. We saw the result is what we need, right? Yeah. Okay, that's the job we we want to know how to simulate the model. Okay, thank you.